Hi scholars, this is Ms. Perez again, and welcome to Unit 5, Lesson 6, Applying the Property of Waves. For today, you are going to need the following tabs open on your computer. Share my screen with you so you can see. So, you need the SOS Applying Properties of Waves website. You need Google Classroom open, and then also the classwork that you have already downloaded from Unit 5, Lesson 6. Let me pull up my PowerPoint presentation. Great. So let's start. So today, we're doing applying the properties of waves. The materials that you should have out are your calculator, your notebook, a pen, or a pencil. I have put a link for a calculator on the SOS website if you need access to something, if you left your calculator at school. Okay, and then again, as a reminder, those are the only tabs that you should have opened. The aim for today will be to apply our understanding of waves to new scenarios in order to predict and describe the properties of a wave. We are going to continue our exploration of sound waves, their properties, and how to use the wave equation to find the speed of a wave. Throughout the beginning of this unit, we examined carefully the properties of waves and examined how the properties of a vibrating string, like those of a guitar, affect the sound that we hear. Today, we are going to apply our understanding of waves to a variety of applications. It is important that we read each question carefully and fully represent our understanding on our pages. So let's start with a do now. In front of you and in your worksheet, you have these two questions. The first one is, what is the wavelength of the wave shown in the diagram below? And then the second question gives us, the diagram below represents a transverse wave traveling to the right through a medium. Point A represents a particle of that medium. In which direction will particle A move in the next instant of time? So when I say press pause now, take the next 2 minutes to solve these problems. Once you are done, press play to join the video again. Press pause now. Great, welcome back. So now let's go over these questions. As I am annotating these problems, make sure to take notes in your notebook and make any corrections if it's necessary. So how do we solve this first problem? We're being asked to find the wavelength of this wave below. And here we have this total distance that's given to us is 10 meters. So we need to determine how many waves there are to figure out what's the length of one wavelength, right? So I have 1 wave, 2 waves, 3, and 4. So I have a total of 4 waves here. And then the total distance is 10 meters. So all I have to do is divide 10 by 4 in order to determine the length of just one part of that, which is 2.5 meters. So my answer here would be A. And now to solve this problem here, before we go into the details, I actually want to show you guys a video that will help us better understand the movement of this particle. So here, while I'm playing this, keep note of the motion of this green dot. As we see, as the peg goes up and down, our wave is being created. So as the peg goes up, we're going from the trough to a crest. And then once it reaches the crest, it starts coming back down again. So it goes up, and then once it reaches the crest, it starts moving back down. So using that knowledge, let's answer this question. So again, this diagram below represents a transverse wave that's moving towards the right. So we know that the definition of a transverse wave is that the medium itself goes perpendicular to the direction of motion. So automatically we know that A has to be moving either up or down. So it can't be left or right. And so based on what we saw in the previous video, we saw the peg, the green dot starting at the crest, starting at the trough, and then it started going up until it reached the crest, and then it's starting going back down again. So that means that this region here, all of the points in this part of the wave are moving up. So then in our video, we saw our green dot going back down. So this whole region here, the green dot was moving downwards. And because waves are cyclical or periodic, it means that this part here will behave in the same way that this part here did. So from this crest to this trough, all of the points along this part of the medium are going to be moving downwards. So that means that my answer is B. Okay, moving along. So now we're going to do a think aloud model that will help you prepare for today's classwork. As I am solving this problem, take note of the steps I am doing to take to solve it. Watching think alouds are helpful to better internalize the material and replicate the steps on your own. So let's do this. I have a periodic transverse wave has an amplitude of 0.5 meters and a wavelength of 2 meters. On the grid provided below, draw at least one cycle of this periodic wave. So I'm being asked to draw my wave here on this grid. So how can we do that? So first I'm going to determine the pieces of information that we're given, and then we're going to move on to answer it. So here I have my amplitude is 0.15 meters, and then I have a wavelength of 2 meters. So how can I translate that into my drawing? So first let's do the wavelength part. So my total wavelength is 2 meters. So that means that if I start here at my origin, my wave is going to end here at 2. And because waves are symmetric, that means that it's going to cross the origin right at this middle point of 1 meters. Okay, so now let's use this amplitude information. So it says that it has a height of 1.5, so that's roughly here in the middle in my grid. And then it's going to be over down here on the opposite side of my axis at negative 1.5 meters as well. Because of the symmetry of waves, I know that my crest is going to be here at this point in between these 2 points. And then my trough is going to be here in between the 1 and the 2 meter mark. So now that I have all of my points, I can connect dots by drawing. So I start here at my origin, I curve up, reach my crest, come back down through the 1 meter mark to the trough and back up. So then that is my wave. Great. If you have any questions about how I do this, please take note of these in your chat and your teacher will address them at the end of this video. Before we move on to today's practice problems, we should keep this stuff in mind. When you're solving a problem around waves, it's important to consider the properties of the wave that are given and those that we can determine based on the givens. For example, if given speed and a picture, we can generally find the wavelength, frequency, or the period. So just like with any other of the physics problems that we're solving throughout the year, we need to be able to determine the information that's been given to us and what can we do to find that information. And finally, before we move on, I just want to stamp these 2 key points. So things that we've discussed previously in previous lessons. The amplitude represents the energy of the wave. In a sound wave, the amplitude is related to loudness. Amplitude is unaffected by changing the speed of the wave, the frequency, or the wavelength. And then the pitch of a sound wave produced on a vibrating string is affected by the tension of a string and the length of the string. To increase the pitch, one can increase the tension or decrease the length of the string. If you did the first lesson of Unit 1 with the string and the cup, this is the main point that we discovered in the lesson. Right? That pitch is affected by the length and the tension of the string. Right? So keep these 2 key points as you move along through your classwork. For the remaining time in class, you will complete the Unit 5 Lesson 6 classwork document that you opened at the beginning of this lesson. If you have any questions, please take note of them and your teacher will answer them for you shortly. Have a great day.